So good morning, friends. So we'll be continuing with the hierarchical modeling methodology or structure. So as I said that earlier, we have two approaches. One is the top-down approaches and one is the bottom-up approach. So here is the example. Example is a 4-bit ripple carry counter. Okay. So as we can observe, it is a counter program, and counter program it is of 4 bits. Okay, so 4 bits the counter, what is the output you are going to get? So it is output will be 4 zeros to 4 1. Okay, so 0 1 2 3 4 5 6, like this it is to reach till to 15, and once it is reached to 15 it should set back to 0. So this is the program which we need to write it. Okay. So to implement this counter, we require a black box. Okay. I'll just draw the black box to you. Okay. So this is a simple black box. Okay. For the implementation of this counter. So this I can write here it as a counter program, CNT. Okay. And for this counter, I have to give inputs. Is it or no? My input is what? One is clock and one is reset pin. Okay. So there are two input pins. So one is clock and one is reset pin. Okay. Then it is a 4-bit counter. It is a 4-bit counter. So I'm having four output pins. Okay. Four output pins. So this is input and this will be my output value. So output value also I should give some name now. So from this figure only you can see my output are Q0, Q1, Q2 and Q3. Okay. So I can write here Q0, Q1, Q2 and Q3. Right. So this is a black box. What is this black box? It gives information about the input variables and gives its information about the output variables. So my inputs are clock, my input is reset, my outputs are 4-bit value, which is Q0, Q1, Q2, Q3. So this is the black box of the implementation of your 4-bit carry counter. So I have to use either top-down approach or I should use bottom-up approach. So you can see I've implemented this carry 4-bit ripple carry counter using some flip-flop. Right. So which flip-flop I'm going to use? I have used T flip-flop. So as it is a 4-bit counter, so I'm going to use 4 T flip-flops for the implementation of the counter. So you could no need of that why you have to use only T flip-flop. Okay, you can use any of the flip-flop. As for explaining here, I am using a T flip-flop. So 4 T flip-flops are used in implementation. Sir, how I got this circuit and all those things. For a period of time, you will understand. Just as of now, as I've shown about given information about the black box, where what is my input and what is my output, and there is some relation between input and output, right? So when I process some input, then only I'm going to get some output, right? And that processing I'm going to use with the help of a T flip-flop. T flip-flop is what? Toggle flip-flop. Okay. So toggle flip-flop is when I give 0, so sometimes it will be 0, sometimes it will be 1. So it is toggling every time, right? Every second it is toggling. That is why the name here we are using it as a ripple. Okay, 4-bit ripple carry counter. It is not general counter, it is a ripple counter. So when I use this ripple counter, so by default, the flip-flop which I'm going to use is the T flip-flop. Sir, how you have written this circuitry, how I have got this one. So there will be a lot of questions for you. Okay, and you will say, sir, top-down approach or bottom-up approach. So top approach, it will be some top level block. Now this top level block, I am giving it as name it as a counter. Okay, this is the counter which I'm going to use. So with this counter, I'm having a sub block. So what will be the sub block you are going to have? So you are going to have a sub block of four values, and these four sub blocks will be. So what sub block will be? It will be T flip flop. Okay, so here I'm going to write it as a T flip flop four types because it is a 4-bit 4-bit ripple carry counter value. Right. Now what about leaves? So leaves have not mentioned. So leaves how I will be mentioned. So from this T flip flop. So how this T flip flop has been built. So this T flip flop has been built with the help of a D flip flop. Okay, which is your delay flip flop and then a inverter. So how this T flip flop implementation? So I am having one more block diagram, which is this implementation of a T flip flop. And this T flip flop I'm going to implement using the D flip flop. Okay. So how many D flip flop will be there? So T flip flop there are four. You are requiring four D flip flop. And one more component is the inverter. And you can see this is the truth table for the delay flip-flop. So delay flip-flop, what it is that if reset is 1, QN is 1, the output will be 0. My condition is what? It is only with the help of the input. Okay. So my reset value is 0, 0, 0. My QN value is 0, 1. So output value will be 1 and 0. This is the only simple thing. Okay, so now looking at this block diagram, I can implement the top-down approach or bottom-top approach. So how that block will be? So as I said that at the initial part, it will be a ripple counter, right? My sub block will be a T flip flop. How many T flip flop? There will be a four T flip flop which I'm going to use as it can be observed in this block diagram. Okay. Now how we are going to implement T flip flop? We are going to implement T flip flop with the help of a D flip flop and a inverter so that you can observe that D flip flop and an inverter, and this is applicable for each of the T flip flops. So you are having four D flip flop and four inverter. And major point you observe, there is no arrow mark given here. So why it is not given any arrow mark? Reason because now if I want to go from the top to bottom approach, my arrow mark will be towards bottom. Okay. Now if I put arrow mark in this way, so what approach it becomes? It will become a top to bottom approach. Okay, top to bottom approach. So how to implement a 4-bit ripple carry counter? So you need to start with the ripple counter as the main block, which is this one. Okay, then sub block what you have to go? You have to go with the T flip flop 1, T flip flop 2, T flip flop 3, T flip flop 4. Then next you need to build this T flip flop. To build this T flip flop, I'm going to implement D flip flop and the inverter. Similarly, for this TFF1, TFF2, TFF3, I'm having D flip flop and the inverter, D flip flop and inverter. If I follow this procedure, I'm going to get the top to bottom approach. No, I want to change it to bottom to top approach. So what I'm going to change? So again, my implementation is same. I want to implement this counter. I'm going to use this T flip flop and I'm going to implement this T flip flop using this D flip flop and the inverter. So what my procedure now how it will be? So I will start with this D flip flop and this inverter and this arrow mark will be towards up. Okay, bottom to up. So I will first create TFF0, then use this DFF, use this inverter gate, and I will build TFF1. Okay, so your all arrow marks will be changed. Is it or no? All arrow marks will be towards up. Now this towards up we call it as a bottom to top approach. Bottom to top approach. So once I have built TFF0, once if I build TFF1, once I have built TFF2, Once I built TFF2, once I built TFF3, then all four T flip-flops are built. And when I combine this one, then finally I'm going to get an output for the ripple carry counter. See, this is only the methodology which I'm using to build the 4-bit ripple carry counter. I have not written any program, right? Any program I have not written. So program how I'm going to build. So first I will write the main program. So this is my main program. Okay. So main program, it is for the counter. So main program, I need to define input and output. So input will be what? Clock and reset. Output will be what? Q0, Q1, Q2, Q3. Then I need to write sub-program for TFF0, sub-program for TFF1, sub-program for TFF2, sub-program for TFF3. So this we call it as a sub-program. Okay, sub-program. Okay, or here we call it as a sub-block. And this sub-program, again, it will call a function for the D flip-flop, and it will call the function for an inverter. So this is how I'm going to write a program for the top-down approach or a bottom-up approach. Okay, so this program, how it should be written, we will be observing in the next class. Okay, thank you.